Hello, everybody. Good afternoon. Welcome to the spring semester 1510. And I'm your instructor, Dr. Ching Ryan. Really nice to meet you all. I'm very sorry that we have to meet in this manner without having the opportunity to meet you in person. That being said, I understand that a lot of you will have your own restrictions and difficulties during this time. And I want to let you know I will try to do my best to accommodate you if you have any difficulties, and if you want some accommodation, please feel free to let me know, and I can do my best to help you. We have a large class. We have 110 students in this course, and we will try to do our best to survive this and still trying to learn as much we could during the difficult times. I want to let you know that you are automatically muted, and your video is automatically turned off when you come into the meeting. I will also, after every time I say hello to you at the beginning of the class, I will also turn off my video just so that it seems to save the bandwidth a little bit better, and we will have more of a smooth connection, especially when internet connection is not stable. Okay. All right. So first of all, I wanted to get an idea, before we're talking about the logistics, I want to get an idea of what you guys think about physics and what physics is about. And there are a lot of announcements regarding the class and the group chat, and I'll get to that later, okay? All right, first of all, let me share my screen with you. I'll take a look at my slides here. Okay. Now, if you have any questions during the lecture, and if I did not see your chat right away, so if I'm looking at my screen, I don't often pay attention to the chat, just feel free to unmute yourself and shout out, and just raise your hands and let me know that you have a question, and stop me anytime you need to, okay? All right, so we're coming to, I don't know, for many of you, it may be the first physics course you've taken, and for some of you, you may have encountered physics before. If you did, that's awesome. If you haven't and you're wondering about, and you feel a little bit uncertain about this class, and let's talk about it. I want to launch a poll just to get an idea of what you think about physics. Do you feel like you love it? There are a spectrum of feelings, and try just to be honest with yourself, and I just wanted to get to know that what you think about physics, okay? So let me launch the poll. So I only have a generic question for every, generic poll for every question I post, so we will tend to update our poll every time we need to vote. So if you're seeing the poll right now, what is your answer choice to the question I posted? So just go ahead and type your answer on your computer, okay? All right, we get most of our results very quickly. Very good job. Okay, so I'm going to go ahead and end our poll, and I'll share the voting results with you, okay? So if you can see our poll results, I'm very glad to see that at least a majority of ourselves find it interesting, and you're looking forward to learn more about it. Very few of you feel like I dislike physics, and I have to be honest that everybody have that feeling once in a while, or occasionally, or at some moments. At the moment they feel like, oh, I really dislike what I'm doing right now, and that's totally common. So let's talk about, before we talk about how we find if it's interesting or if we dislike physics, we need to talk about what it is. So what is physics? Anybody would like to tell us what they think physics, the subject? What is this subject about? Anybody like to unmute themselves and share their thoughts with us?
I think study or physics would be the study of how things interact in the world that we see.
Is this Clement that you're talking?
Yes, it is.
Thank you so much. Thank you so much for sharing. Yes, it is about the interactions and how things are connected in this world. And I actually talk to my son about what is physics, and sometimes um, I couldn't find better words to describe what it is. I just simply get lazy. I say it is the study of everything, because it is true. It is the study of everything, from something big in scale, from astronomical object, to something really tiny like atoms or quarks, and something that we see in our phenomena, natural phenomena like moonlight sunset, uh, to something we use in everyday life. Microwaves, your tablets, your phone, something we enjoy watching, like if you enjoy watching sports, you can find physics, how it affects the motion of the ball and the movement of the joint of the athletes, airplanes that, stuff that we use and are very useful to humans. So it is relevant to every one of us, um, and something so relevant. And another thing that it takes a little bit curiosity to do physics, and it has, every one of us has curiosity in us, because if you watch babies, right, they were very curious. They will watch something and let it and drop it from their hands, and that's because of gravity, and they think that's interesting, so they keep doing it over and over again because they're curious. So we all have that curiosity in us, and we all find it have a very relevant to our lives. So because those reasons, I believe everybody has the potential to learn physics and to enjoy physics, and we have the ability to do it well. So I believe every one of you has it in you to enjoy physics and find it interesting. So what I encourage you to do this semester is just feed into that curiosity that you already have, and make the best out of this. So physics, with all the phenomena I just mentioned, it seems very chaotic. Those two phenomena may not look similar at all, but um, they underlying that chaos, there is this simplicity, the beauty of pattern that people find can be described by physics laws. So that is what we're doing. So in 1510, we're trying to seek these laws and patterns to describe motion of the object. So that's the mechanics. And in 1520, we will move on to electricity and magnetism. So we're continuing to do that, searching and applying the patterns, applying the laws to describe this chaotic phenomenon that is around us. So for example, in this semester, things that you will learn, and I will remind you when we get to it, you will be able to explain in physics terms, using physics laws, how a rocket works. You will be able to explain to people why won't you fall off the roller coaster when you're upside down. And you will also be able to explain to people, why do cars have chromosomes? What is the purpose of building those? And there are more than that that you can answer with physics laws and principles. So I find these would be very useful to us, because later on when you see things around you in life and you watch TV, you will be able to think about, oh, I know this particular physics is applicable in this situation. So there are two learning goals for this course. The one thing is the conceptual understanding. We cannot really do and understand physics without knowing the concepts. We achieve to have a good conceptual understanding by, in class, I will post these sort of, used to be clicker questions, and now it will be in the format of a poll. And we will discuss these concepts in class. And the second important goal for the course, of course, we need to learn how to solve problems. And problem solving skills is very important. If you ask your professor in your own profession, they will probably likely to list problem solving as one of the important skills they want you to be able to get out of physics class. And you will have to do problem solving in your own major as well. So that's what we need to do. So in our exams, you will also see a mix of conceptual questions as well as sort of numerical calculation questions. And that is built around the two goals for this course. Okay, so our textbook is free. It's the OpenStax textbook online, and I'll show you the link to, there's a major link, and I have a link that's built in for each particular chapter, and I'll show it to you when we get to it. First of all, I want to walk you through our Blackboard site and just kind of show you where everything is, so we get an idea where to look. So let me share my browser with you, and I walk you through our Blackboard site. 1 second. Let me bring my browser to the front. Okay. I think it's here. Okay. All right, so this is, if you're seeing my browser right now, this is our Blackboard site. Click start here. You will be able to see sort of a very short description of what this class is and some of the next steps for you to follow. And if you click course information, you can see our syllabus and our schedule. This is a tentative schedule telling you what topic we would like to cover at what day. Most likely we try very hard to keep our schedule, but then maybe we might be a little bit faster or slower to our tentative. And if you need to find our Zoom link again, you can always come here and without going through the announcements. And inside the weekly course materials, so you can see there is a folder for each week with the relevant content for that particular week. And if you click into it, I will also, after each class, post our lecture notes and videos under the weekly folder. And then in terms of assignments, I want to go to the Flipped Physics, and also I will walk you through the Flipped Physics site. So before I exit out of this site, I want to show you, in the beginning, we have something called a pre-assessment. So we don't have any other assignments this week. I will not count your credit for pre-lectures. There will not be a homework due, but there will be a pre-assessment. So the goal of this pre-assessment is a survey for us to gather some understanding of how your prior knowledge about physics, your intuition about mechanics, and it will not be graded, which means it's very low stake. You don't have to stress about it, but try to give your honest participation and do your best, because that helps us understand how students learn physics. And to encourage you for your honest participation, we give a 1% extra credit for completing it with a good faith effort. And this assessment, you can simply come here and click on it and do it with a 45-minute time limit. And it's open until next Thursday. So you have a week and a half to do this, okay? And you don't have to Google answers because again, it's not graded. Just try your best and do this pre-assessment. Okay, so now I want to go to the Flipped Physics, because on that site, we have pretty much the chunk of all the parts that will count into your grades. And I understand there had been some difficulty. Some students had told me that the system required Flash. There was turned out to be an update that the system made, and we had switched back. The program had helped us to switch back, so it should be working now. I also want to ask, any of you have successfully registered and are able to view the course? If you have already done that, could you please tell us? Anybody have done that?
I was able to.
Okay, good. I just want to know because some student had a trouble. I don't know, maybe it was a momentary glitch the system had with registering. And I tried it with another email address of mine and worked. I just want to make sure that it is at least working for more than just me. Good. So please go ahead and register on Flipped Physics. So let me go to the site and walk you through what are we going to do for here. Okay, so if you go to the Flipped Physics site, you will get access as a student. Go to student and use the email address. You don't have to use your Cal Poly email, because the way I identify you is later on, you enter your name and your Bronco ID. So use any email that you want. And I recommend that you enter your name later in exact same format as it show up in your Bronco Direct system, so that I can easily match your credit in here to my roster. And then you can also enter your ID so that we can identify you in 2 ways. So go ahead and register, and once you and then you will be prompted to register for this course, and there is a course ID as of fall 2021, fall spring 2021 QR, my initials, and that is in your syllabus. So use that code to register. So once you register, you will be able to see. Let me log in so I can show you what it looks like. You will be able to see this course, and you will see what is due each week. Now, I would normally recommend you go here to this calendar. You can see this is the calendar button. Click that, and it show up in here. I think this is a better view, and you can see clearly on this calendar what is due which day. I'm not gonna count anything for the first week. We'll start counting credit only starting next week. So it give you some time to get registered. So these blue tabs are pre-lecture videos. Now you can watch that and get an idea of what is going to be covered in this week. Give or take, sometimes we may not be able to cover exactly on the same day, but maybe next week. And you are coming to the class more prepared. You know what question to ask, you know what to pay attention. Now, if you click view, you will be able just to look through these slides one by one and knowing what is coming. And there are some built-in questions that help you check your knowledge as you go through them. Now, at the end of the pre-lecture, now if I go back to my calendar, we have this thing called checkpoint questions. And click view again. There are a few questions just to check your understanding of something you watched. And we will go back and talk about these checkpoint questions. Not all of them, but the ones that you have difficulty with in class. Okay, so you will be given credit for doing these pre-lecture videos and the checkpoint questions in here. The yellow, these yellow bars, these are what I mentioned about the links to the OpenStax textbooks. So for example, here, we are starting to talk about kinematics in the next day of class. So you can click this link and that will give you the chapter that we're going to be covering. So let me see. Oh, there seems to be something wrong with my link. I'll have to update this with the first one. The second one works. So for example, I clicked chapter 2, vectors and 2D kinematics. Here it gives me, you can read this, and this will be free online, okay? There's no way for me to know whether you read it or not, so I can only give credit for the pre-lectures, and the reading is simply just a tab here for you to follow, and you can read it before class or after class whenever you feel like you need to review and find something. So the link is here. And the red ones are our homeworks, online homeworks. And again, you can go ahead and do it. I set 2 deadlines for each homework. If you finished by the first deadline, you get 100% of the credit. For the problems, let's say 2 out of 5 problems you finish on the second deadline, which is a week later, you'll get 80% of those credit. Just to encourage that people continue to try to do these problems. That's why I set up 2 deadlines, so you still have time even if the first deadline passed. Okay, so that is the Flip Physics site. Before I exit out of the Flip Physics site, are there any questions regarding Flip Physics and how to set it up? It will be free for about 21 days, or give or take. In the past, it's always been 21 days. So after 21 days, I think there is a fee of around $39, maybe $40 or something like that. you have to pay to continue to use it for the rest of the semester. So for this entire semester, the one thing you need to purchase is the access to the site, okay? Are there any other questions before I move on to talk about the other stuff?
Do you know where we purchase the access to Flip It Physics?
You, what do you purchase? You register here, and by the time when the free trial expires, it will prompt you to pay here on the website. Was that?
Sorry, quick question. Do we use our school email address to sign up for the website, or?
You don't have to, because you will be identified later on, ask you to enter your name and Bronco ID, and we'll use those to identify you. You can use your school email, but you don't have to use your school email. And I recommend when you enter your name, make sure that you enter it exactly the same way it showed up in your Bronco Direct system. It will be last name, comma, is the first name and middle name. In that format, that will be easily paired with the roster later on, okay? But even if you enter it wrong, I can still find you, but it would just be more manually. I have to find you manually. And your Bronco ID is another way for me to identify you. Okay, are there any other questions?
Will we be taking exams through this website?
No, exams will actually be on Blackboard. So when the exam comes, I will have it open for 2 hours window, and I'll tell you on this day, you can open it up whenever you want, and then you have 2 hours to do the midterms, and then just do it on Blackboard. And it will be open book and open notes on Blackboard, just that you cannot collaborate with another. You cannot talk to each other, but you can look at your notes when you do it online.
Okay, thank you.
Okay, all right, so that sums up our grades. These pre-lecture videos and checkpoint questions, as they're accounted for completion. You don't have to do it correctly, of course, because at the beginning of the class, we don't expect you to know it already. We just want you to do them, and that counts 10% of your grade. Online homeworks on the same site counts for 20% of the grade, and the rest of that will be 2 midterms and 1 final. That is on Blackboard, online, open book, and open notes. Okay, so I want to say a little bit about online homeworks, because even though you're doing your homework online, I still recommend you try to write it down and keep a note for yourself. So let's say you have a notebook and you just wanted to use that for all your homework and keep all your solution for your homework that you did online. The way I encourage you to do that is you can have a record. It will be good for you to review them, to be able to find out the mistakes you made, and just treat it as if you have a written homework. And if you can, it's always good to find more practice to do on your own. If you want to have more problems to do, you can ask me. I will try to post a few for you if you need. But the textbooks is always good to find more practices, the back of the book textbooks problems. And sometimes students might get confused of, oh, I've looked at my book and I looked at my homework, I reviewed them. How come I didn't do well on the exams? The reason for that is by looking at them, it's different from by doing them and know how to work it out on your own, right? We can look at a worked out solution someone else wrote and every step makes sense to us, but that's not the same if you have to reproduce it yourself. So a good way to check and to test yourself is to present yourself with the problem and don't look at the solutions and try to write it out on your own. And if you can work it out, and then you know, okay, I actually mastered this part and I'm going to move on to something else. So that's another way that I encourage you to keep a note for all the problems that you solve and the homework that you work on. Of course, working with peers is strongly encouraged. Collaborate on homeworks is totally fine, as long as you understand that the answer you're putting in, instead of copying the answer, you need to know why you're putting in the answer. You understand the problem. So you have to collaborate remotely, or if you a few of you could get together in the small groups, that would be really great as well. I wanted to let you know about a recitation class. I'm not sure if you heard about it or if some of you may have enrolled in it. It is not required, it's an optional class. However, it is very good practice because it's a credit, non-credit course, meaning that you're not going to be graded. You're only there for the practice. And it's, I believe for this semester, it's taught by Dr. Cora Wheeler on the Wednesday. It's an activity class for about 2 hours, and you will be given some extra practice and problems to solve. And those will be very helpful for you to get some extra guidance and extra time to do the practice. It's kind of attending office hours you have to spend time working and practicing anyway. So if you're thinking about it, I recommend you register for the course if you can, and if you're still available, okay? The extra credit, I have talked about this already. That is a pre-assessment. There are 30 multiple choice questions, and you will get an extra credit added onto it, and you have until next Thursday to do this. Okay, so that is pretty much everything we need to talk about for logistics, the grading, the textbook, online homework, and all of that. For the rest of today, I want to spend the rest of the time start talking about dimensions and units. Before we move on, are there any questions for me for logistics for the class?
So for the Flip-Its, the name should be last name, middle name, then first name?
So take a look at how it show up in your Bronco Direct system, and you can just copy paste that into your Flip-It Physics site.
Ah, thanks.
Yes. So that just allows me to do a matching really easily. Like if your name is in the same order, and then I list alphabetically, and I can match your grade really easily.
Sorry, where did you post the link?
For what?
For this website, the physics things, the flip.
Yes. So if you go to Blackboard, okay, later on I will be sharing this particular slides with you, and you can see I have the link here, right here, physics.com, and this is also in our Blackboard site in the weekly folders. In every week, it always reminds you do the pre-lectures on Flip Physics, and there's a link there as well. Thank you for the questions. Are there any other questions before we move on?
Is the pre-assessment assignment, is it on the Flip-It Physics or is it on Blackboard?
Yes, the pre-assessment is actually on Blackboard under the weekly folders. At the beginning of the week 1, on top of the weekly folders, there is a pre-assessment.
Okay, thank you.
I wasn't able to find the assessment, and then also, is the $40, is that per month or just in total?
For total, the entire semester. Were you able to see the assessment, or were you not?
No.
I think
was
it's
not.
hidden on your account.
Okay.
Yeah, it says on Blackboard that it's hidden for students.
Ah, okay. So let me take a look to make sure. I just need to make it available. So I will go ahead and make it available right away, and you should be able to see it.
When did you say it was due? In a week?
Next Thursday.
Okay, thank you.
Okay, so now it should be available, okay? You should be able to see it. Okay. Very good. Are there any other questions before we move on to talk about dimensions and units? Okay, if you think of any questions, feel free to shoot me an email and just let me know anytime, okay? So before we start our discussion about the motion of the objects, we wanted to talk a little bit about dimensions and units. The dimensions are simply the type of quantities. In physics, we deal with measurements. We deal with a lot of quantities, and there are 3 main types. That is the length quantity, a mass quantity, and the time quantity. Right, so for example, we say, oh, it took me 5 minutes to walk there. I'm talking about a measurement of a time quantity. Or if I say this room is 20 feet long, I'm talking about a length quantity. So it's simply telling us what dimension this is, what type quantity you're referring to. And these three are the most basic quantities. Just like the primary colors, you can mix 3 colors to pretty much get any color you want. The other physics quantity can always be breaking down into the combination of these basic 3 dimensions. And oftentimes people use the word dimensions and units interchangeably, but they're really different things. Now, dimensions are a type of quantity, but units are the standards that we need to make measurements. So for example, we're gonna say, okay, to measure the length dimension, I measure it to be 5. I give a number, but then people might ask, 5 what? 5 feet or 5 inches? So these are described by units. The feet, inches, or meters or centimeters are units. Sometimes we talk about kilograms or grams. Are we talking about the units for mass? To be you have to be careful about. Sometimes we say pounds, but it's actually not a measurement for mass. When we say pounds, it's actually a measurement for weight. So here is actually a weight dimension instead of a mass dimension. So last but not least, we are having a lot of units for time, which is we say hours, minutes, or seconds. These are all the different units we can use to describe time. Of course, these are just examples. There are many other units. And a lot of times people in different disciplines use different units, right? In engineering, you may use different units than what we commonly use in physics. So people choose the proper units to whichever makes sense to them. For example, if you're talking about the measurement of football field, it wouldn't really make sense to measure it in inches because you're going to get a large number. It makes more sense to talk about yards or even meters. So you choose appropriate units for whatever you're trying to measure. So why dimensions are important? Because it's a very important tool to do dimensional analysis. It can help you check your answer to see if it is correct. For example, you can get your answer, you're trying to work out a mass as a result, but in the end, you check your dimension, you didn't get a mass, you get a seconds or something. So you know that, oh, I probably have made a mistake in my calculation. Let me go ahead and do it again. And simply dimensional analysis is another way for physics just to discover new physics, physicists to discover new physics. And we will have one particular example today to show you how we use dimensional analysis sometimes simply just to guess what the result is, to give us a good intuition of what it's going to be like. Before we continue, let's go ahead and start with some, now it used to be called clicker questions, now it's just poll questions. So for example, here we use x and t to represent 2 different quantities, x to represent distance and time to represent time. And you know that now the distance would be a dimension, the length dimension, and here time would be the time dimension. And to do dimensional analysis, for example, if we have an equation, x equals 1/2 ct squared, and we will be able to find out the dimension for the constant c in there. So what do you think the dimension needs to be in order for this equation to work? I will give you about 2 minutes, and I'll break you down into groups. So I'm going to simply assign breakout rooms randomly. We won't be able to pair you, I'm sorry. So I'll have about 28 rooms, and then each of you will be in a group of 3 or 4 and take about 2 minutes to discuss, and then we'll come back to do the vote, okay? So I'm going to go ahead and open the rooms for all of you. If you see the prompt, just click join. So as we come back, please go ahead and put in your vote for the poll that is in progress right now. Okay, so as we gathered majority of the votes, let me go ahead and end it and show you the results. So we have majority of you voting for C, and some of you kind of tied for A and B. So let's take a look and see what we mean by dimensional analysis. So if you have an equation, the two sides of the equation has to have the same dimension, or in other words, have to have same units, because we cannot equate a mass to a time, right? It wouldn't make sense to say 10 kilograms equal to 20 seconds. You know, those are apples and oranges, cannot be put together. So if you see an equation of something equal to something, that means they have the same dimension. So if I'm saying, okay, what about the dimension of X? Now we know that is the distance, so it has the dimension of L. So we put them into dimensions. We usually do something like this. We will say the dimension of X is equal to the dimension of whatever comes to in the right-hand side. We're going to put it in the brackets, meaning that we're taking the dimension of that unit. Now the dimension for X is the length, so we put an L here, right? L equals to the dimension of the rest of them to combine together. So what is the dimension for in 1/2? What do you think? It's just simply a number, right? What is the dimension for a constant?
It's
There
universe.
is no, yeah, there is no
It's
dimension.
dimensionless. Yes, so not, a constant has no dimension, which means it should be, how do I represent it? It has to be 1, right? Not 0. If I put a 0 and make everything on the right-hand side 0. But if I put 1, meaning that you multiply that by something else, it doesn't change the dimension of something else. So make this quantity a dimensionless quantity. So 1 comes from the 1/2 dimension, and the C is something we're trying to figure out. And T is time, so you have time square dimension. So putting together, you get the dimension for C is going to be length over time squared. Very good. So you have chosen C, and that is the correct dimension. Very good. So this is simply a very straightforward example showing us how to do dimension analysis. Is by looking at an equation, you can guess what this quantity has to be from the other equations. And you probably have already guessed if you have read your textbook ahead of time, or if you know some physics before, that a length over time squared is a acceleration dimension. So this C variable actually represents an acceleration. Okay, let's look at another question. So have done that. This one I will not give you breakout rooms to discuss, but you could vote on your own, or if you want to chat with another, that's okay too. Here we give you little m that represent a mass dimension. V represent a speed. Now you need to think about how do you represent speed using the basic dimensions, the 3 basic dimensions. And K has something else that's given. So what would you think the little k has to have? Okay, I'm again, go ahead and I will launch the poll for you to vote. You can think while you vote. I'll give you a minute or two. There's no rush, okay?
Daddy, chill.
Okay, as we gathered pretty much all the votes, let me stop the poll and then I'll share with you the results. You can see we have a majority voting for E, but we do have quite a few votes for other things as well. Next thing is D, is more popular than the other choices. So let's take a look at this together. So again, it's like solving a variable using an equation, right? If the equation has to left-hand side equal to the right-hand side, then we know that the dimension for capital K has to equal the dimension for little k times the dimension for mass times the dimension for the speed squared. And the capital K is given, so we can simply just plug that in. It's a mass times length squared over time squared. And you have little k, which is something we're trying to figure out. And the mass give us mass And what would be the dimension for speed? What is the speed dimension? Anybody like to tell us?
Length.
And time.
Yeah, length and time. How do I combine length and time? Remember, length and time are the three basic dimensions, and we combine the basic dimensions to get any other quantities we need. So how do we combine length and time to get speed?
It would be length divided by time.
Yes, length divided by time. Very good. That's how we combine them. So in this case, we'll have 1 squared over time squared. That gives us velocity, speed, if we're talking about the magnitude of that. So you can see that the left-hand side and right-hand side, in order to be equal, then this little k dimension has to be 1. So it has to be simply a constant, which is a dimensionless quantity. That tells us what this constant has to be. So in physics, that is in fact an approach that physicists use sometimes to guess. Okay, so if I need a variable, what kind of variable am I talking about? To make it a little bit more concrete, I will show you an example of how people do physics using dimensional analysis. For example, let's say you want to find an expression for the period of the pendulum. Pendulum is really just you hand an object to one end of the string, and you simply let go, and then the object just swing back and forth, like the clock is a pendulum. So the period is defined to be the time it takes for the pendulum to go from one end to another and then comes back up. So it's one entire circle. So one entire from the left-hand side to the right-hand side and back to the left-hand side. So that's the period of pendulum. So we wanted to find an expression for the time, how much time it takes. And let's say you're a physicist, you're trying to figure out this problem, and you're thinking to yourself, I wonder if the mass would have any relevance to it, because it might. If you tie the end of a big object to a string versus a smaller object to the string, you think that may make a difference. And you also wonder, I wonder if the length of the string will make any difference, right? Use a longer string versus a shorter string. So you think about all the possible variables that might enter into the picture. And the next would be using dimensional analysis. How can they be combined to get you the period for the pendulum? So let's say this is a problem you're trying to figure out as a scientist. You don't know the answer already. You don't, let's say you haven't done an experiment. You just want to say, in theory, can I figure out something? So I give you some time to try to work it out in groups, and we'll at least talk about ideas, and then we will come back and do this problem together. And let me go back to my breakout rooms, and I'll open them up again. I'll give you about 5 minutes on this one because it's a longer problem, okay? Okay, as we all come back, I would like to ask what are the some thoughts that have been brought up in your discussion. So how do you go about, let's say, as a scientist to try to find expression for the period of a pendulum using the other variables that are given that might you think might be relevant? So what are the thoughts? Any people would like, any group would like to share what they talked about with the rest of us?
I could share.
Okay, very good. Tristan, right?
Yes.
Yes, thank you so much.
So I started with looking at what we were looking for, which was the time for the period.
Okay.
And then I looked at the other factors that we could consider. I
Okay.
ignored the mass of the pendulum bob because mass never really shows up anywhere else in
Okay.
the final answer or the factors.
Okay.
And I kind of got stuck with the gravitational field because that's expressed in meters per square second, and we're looking for seconds in the final answer.
Mm-hmm. Right. So if you're trying to think about, okay, if I can combine the rest of the quantities in a certain way to get me the time, yes, I would say you absolutely have the correct idea. You're on the right track. We just have to figure out how do we combine and manipulate these variables so that they give me the seconds, the time that we wanted. Very good. Any other thoughts from any group?
We discussed that I think there's something having to do with like circle because it's moving like in an arc.
Yes, thank you. So what about the arc? How would that, affect the expression?
Um
The arc is the amount of distance, right? That it covers. So
Yes.
that would probably affect the
Yeah, that is an arc. Yes, so you can think about the length of your string and the mass and the gravitational field may also affect the arc in the sense that how much distance it goes through. But let's say that at first your relevant quantities that you want to see are the mass, because that's something that you make a pendulum, right? Once you make a pendulum, I think the mass and the length and which gravitational field it is in are the most relevant and intuitive quantities you're giving with. So let's see if we're just trying to combine these quantities. And earlier that was shared that mass does not enter into the picture. I just want to say actually it is true. You want a second, so if you enter the mass into the picture, eventually you need to get rid of it. And how do you get rid of it? Probably it's not to bring it in the first place. But let's say at first we didn't know. So let's just lump everything together we can. So we wanted to get a time for the period. So I'm just gonna write that okay, so for some reason, I'm gonna share my screen one more time because it's not updating on my, can you guys see my screen as moving up and down?
No,
No, it's stuck in the
it's
period.
stuck.
Okay, so I need to stop share and share it again. Okay, so let's say I try to get a dimension for time. I'm trying to combine all the possible variables together to give me time. Okay, so I say mass may enter into the picture. I'm not sure. The length of the pendulum may enter the picture, but I'm not sure. And whether you build a pendulum on Earth or you move it on the moon, that may matters. I'm not sure. That's okay. We're saying if they all come together and get combined, they may carry some variables. So let's say mass to the power of A is simply a number, length to the power of B, and gravitational strength, G, little g, to the power of C. I don't really know how they combine, but I'm just gonna throw it out there. And there may be some kind of constants in here, but constants are dimensionless, so it doesn't really matter. So there may be some kind of constants here. So if I want to do a dimensional analysis, saying I want to get a time, so which means they better all come to be equal. This one will give me a time dimension, simply is just t. Mass will just give me a mass dimension. Length give me a length dimension. This is meters per second. So that is in terms of dimension. This is the units. If I want a dimension, is a length quantity over time square quantity. So that would be length over time square to the power of c, right? So they all have to be equal. And you can see again, it's like solving an equation. So I continue to work it out. LC times t to negative 2c. Okay, and I combine these two together to be b plus c, the exponent add to t to the negative 2c. Okay, so that is the left-hand side and the right-hand side, and they have to equal. And you can see, as you have suggested, one of our students suggested that mass should not enter into the picture. Indeed, this has to go away, otherwise they will never be equal. So I need A to be 0, which means mass should never enter into the picture. And I need B plus C to be what? What do you think? So I want the left-hand side to be a T only. The right-hand side now has an L. What do I need B plus C? I need B plus C's to be 0. Yes, yes. As you enter in the chat, it is 0. L should not be in the picture as well. And you have negative 2C has to be equal to. So you need the time to be equal to time. Yes, that is 1, correct. So I solved all these constants to be A equals 0. C is equal to negative 1/2, and B has to be 1/2 because B plus C has to be 0. So you can see that by dimensional analysis, I go back to my expression and I say, okay, if some of these quantities will affect your pendulum, mass shouldn't matter. You will have L to the power of 1/2, and you have G to the power of negative 1/2. You may have some constant. So it is proportional to this quantity. And I use this little fish sign and to say is proportional to the right-hand side. So T is actually depend on length and G. I can write it in this way, is square root of L over G, the length of pendulum over the gravitational acceleration, the gravity constant G, which is some constant on Earth. So this is simply just, you can call it guessing, but it's better than guessing. It is an intuitive way for you to explore the nature, explore the relationship of these quantities, how they may be related to one another, simply just by using dimensional analysis. You haven't done any experiment. And you can see that this is a very powerful skill and a very powerful tool for physicists to help them understand the world. So, okay, so we may have time to do just a little bit more. Okay, so this is my solution. As you can see that I have written in here already. And we will talk about pendulum later on in the course, and I will give you an expression, a more exact expression, but just by doing dimensional analysis, you can already guess what it's going to look like. Okay. So we have a little bit of time, so let's try to do maybe a couple more questions together. So first question here, again, it has to do with dimensions. In astronomy, people use light year to refer to how far light travels in a year. So what kind of a dimension do you think it is when we talk about light year? I'm going to go ahead and launch the poll for you. Okay, so we have 103 out of 107 voted. Just a few seconds to wrap up the vote, and then I'll share the results, okay? Okay, any other votes? I'm gonna go ahead and end the poll, and then let's take a look. Okay, all right. So here is our votes, the results. We have the majority voted for D, meters per second, which is representing a dimension of speed quantity or velocity quantity. And the next vote is for meter, that's the length. And there's some votes for time as well. So anybody would like to talk about what do they think? How do we figure out which dimension light year is? Is it telling us how fast light travels? Is that what we're trying to measure?
A light year is the distance that light will travel in our time year.
What the distance of light travels in a year? Because it says how far. It's the definition is how far. So it is talking about the distance. You're right. It's talking about the distance it travels. So distance is what kind of a quantity? It's not a mass quantity. It's not a
Length quantity.
It is a length quantity, yes. So it is actually C. It's a length quantity. C is correct. Now light year can be confused.
But isn't it a distance?
It is a distance.
Specifically over a year? So shouldn't it be speed?
It's talking about how far it travels in a year. We just decide to be using the time to be a year. If you're trying to reduce the quantity, how should I put it? You don't have to focus on in a year or whether we decide to choose to look at how far light travels in 2 years or half a year. We have to decide some time to do this measurement. But the focus should be how far light travels. We could very well be doing our convention to be how far light travels in 2 years. And that's still gonna be a distance quantity. Does that make sense? The way to use light years is just because these astronomical distances are so huge, using light years is a little bit easier, because if we use anything else like meters, that's going to be a really gigantic number, and we don't really have a good intuition how far that is. But if we say, oh, the distance between these two galaxies are 20 light years, that people know, oh, the distance is this much distance takes light to go 20 years in between them. Does that make sense? So it's a measure for distance. So as I said earlier, we can simply take a look at this question. We don't have to vote. Just to give us an idea how far that is and why do we choose a unit light year instead of using meters. Now, if you were to use meters to find how far light year is light travels in a year, and this is the speed of light. Speed of light, 3 times 10 to the 8th meters per second. And then you use all the seconds in the year, right? So there are 365 days in a year. And there's 24 hours in a day, and 60 minutes in an hour, and 60 seconds in a minute. So if you put all of them together, that gives you a gigantic quantity in terms of how much meter it is for a light year. Okay, so the answer to this is E. And again, you can see these are some of the unit analysis where you could cancel out minutes and minutes, hours and hours, and days, and you will end up to be give you a meter. Eventually, will give you a length quantity. Okay, so that is all we are going to talk about today for units, dimensions, and units. Starting on Thursday, we will start our analysis of a motion in 1 dimension. So if you have questions, I was looking at the chat you guys were posting. Seems like the link, the link to Flipped Physics for registering email can be a little bit wacky. I'm really sorry that happened. And I see some people say you have to click multiple times, but eventually it works. If your Cal Poly email doesn't work, try a different email. I myself tried a Gmail account first and didn't work for some reason. I tried another email, it worked. Or maybe you just have to try it a different time. So try to get that registered, and we can start counting our credits starting next week. But there will be a pre-lecture if you want to do it, posted for our Thursday class. So you can, well, more than welcome to start doing that as well, okay? So if you have any questions, yeah, so people say a Gmail account worked easier. There is a Discord. Is there a particular Discord you guys want me to share with the rest of the class? Please, can you please email it to me? Email it to me and I will share the Discord with the entire class. You'll be able to communicate there. Does that sound good? I see it.
Yes.
Okay, so I'm going to simply copy and paste this Discord and to be, oh, I see multiple ones, but I will just share the ones that everybody posts here onto Blackboard. So you can choose whichever one you want to attend. The pre-lecture do count for your credit. The pre-lecture and clicker question together count for 10% of your course grade. Okay, so very nice meeting you virtually all, and I will see you guys on Thursday. If you have any questions, think of any questions about the class, just email it to me. And I want to remind you there's a survey for the office hours, what office hours you want to attend. And please fill that in by the end of this week, and I'll announce the office hours for next week, okay? All right, bye everybody. Have a nice day.
You too.
Thank you.
Thank you, Professor. Have a good day.
Thank you, Professor. Have a nice day.
Thank you.
Thanks, Professor. Have a nice day.
Thank you.
Bye, bye everybody.